Okay, so hello everyone, good evening. Can you hear me? Hello.
Yes, please. Yes, please. Good evening, sir.
Yeah, good evening. Okay, so we are waiting some minutes, then we'll start. Okay, so we will start. So basically, today is our seventh number of class, and I hope already all of you get all of previous recorded class, as well also get the materials such as a practice code or other material you already get. No problem. And after completing the 3 hours class, then we talk about the problem solving regarding the assignment or other things. Okay, so let's go ahead and start. So let me share my screen. Okay, can you see my screen? Is it visible? Can you see my screen? Is it visible? Basically, today I try to discuss about this type of topic, mainly change detection. How we can easily make the land use and land cover change detection using Google Earth Engine, as well as we also discuss about the NDVI change detection, mainly vegetation change detection. We also discuss and NDVI classification, how we can easily make the classes according different types of range and how we can make the NDVI classification. Also discuss about that. Then extract the dense vegetation using thresholding technique. We also discuss about that, as well as class-wise land use change detection in one layer using Google Earth Engine. We also discuss about that. Calculate the transition area, transition land use land cover area between two time period. We also discuss about that. And also we monitor the urban development and urban growth, how we can easily monitor. We also discuss about that. And finally, we discuss about that hyperparameter turning for improving the accuracy of your machine learning model. Okay. So let's go try to discuss one by one all of topic. So first of all, this is our previous code. Okay. So in this code, we try to make land use land cover map using this satellite imagery. So this is our satellite imagery. So from here, we can easily make this type of land use land cover map, and we try to classify the urban area, build up, water body, vegetation, and barren land. So this is our land use land cover map, and here we find out the accuracy. Mainly, you can see we find out the accuracy 91% accuracy. We find out, okay. But when you find out the best number of trees, basically, best number of trees, when you find out, then you also get the more better accuracy. So in this case, we try to apply the 150 number of trees, okay, but we randomly put it, but we are not sure which number of trees provide me the best accuracy. Okay, so these things we can also monitor. Today's session will discuss about that, how we can easily find out that best number of trees. Okay, and it's called the hyperparameter turning. As well as I also discuss about that. Here you can see, here I already create the 2 decade NDVI map. One is the NDVI image 2020, another is the NDVI image 2015. Okay, so now from here we try to find out the change detection between the 2 year 2015 to 2020. Okay, and finally we also discuss about the land use land cover change detection. So for this case, I already make one land use land cover map for the whole country boundary of Qatar. And here I use the Landsat imagery, and then I try to classify the vegetation, then water body, sand, land, and build up. Okay. So in this case, we find out here the 2 decade map. Here you can see this is the map 2023. Another is the 2013. Okay. So from this 2 decade map, we try to find out the change detection. Okay, how much urban area increase, or how much water body decrease, or how much vegetation loss. So this type of things how we can easily calculate or monitor. So in this class, I will try to explain about that. So here you can see this map I already created, and how I can create this type of map. Previous class I already discussed how we can easily apply the machine learning, mainly supervised, unsupervised, and make the land use land cover classification. So today's session I will explain about that how we can easily make the change detection, okay, between this 2 time period. In this case, year of 2023 and 2013. So between these 10 years, how much build up increase, or how much water body decrease, how much vegetation decrease. So this type of change detection analysis we also explain, as well as we also make the change detection map. Okay, so I'll try to explain all of those things one by one. I hope you can easily get this idea. And when you create any kinds of map, then you can easily apply the change detection things. You can easily apply. Okay, so let's go. We try to explain here this type of green color indicating about the vegetation, then blue color indicating the water body, then sand and build up. I already add the lesion also. So this is our code for land use land cover classification. So these things I already explained. So in this case, we try to make the map year of 2013 and 2023. So just we simply separate the two images. One image year of 2013, another image for year of 2023. Okay. Then we just apply, make the land use land cover classification map. So just we take the training sample from our satellite imagery. So here you can see this is the satellite imagery. So this is the satellite imagery 2023, and this is the satellite imagery for 2013. Okay, these two satellite imagery we simply get from Landsat imagery, mainly Landsat 8 we try to use in here. And further we take the training sample. Okay, so we take the training sample for vegetation, water, sand, and build up for year of 2013, as well as we also take the training sample from year of 2013 images. Okay, so we make the differentiate. Okay, 2 times we take that training sample. So when I take the training sample for 2013, then simply open the image for 2013. Okay, just open this image, and I take this training sample for vegetation, water, sand, and build up. And same as I just open the year of 2023, this imagery, and also take the training sample for vegetation, water, then sand, and build up. Okay, we take this training sample. So we take the training sample 2 times separately. So that's why in this case we also get the more better accuracy. So if you check the accuracy of our map, we find out that one map 2013 97% accuracy, another is the 96% accuracy, because in this case I just use the 2 time training sample for my 2 images, one image 2013, another image 2023. Okay, that's why I can get the more better accuracy. Otherwise, if I take only for the 1 year training sample, suppose year of 2013, then we are also not get the more better accuracy. Okay, so that's why when you want to create this land use land cover map for different year, you try to take the training sample for different year imagery. Okay, individually we take the training sample and run our model, then we also get the more better accuracy. So in this case we can get this type of accuracy, and we got this type of land use land cover map. So here you can see we got this type of land use land cover map 2023, and this is the land use land cover map for 2020 13 and 23. Okay, so we got this type of map. Okay, so this is the map 2013 and 2023. You can check lot of build up area increase. Okay, you can see a lot of build up area increase in the 2023. Okay, so now we try to make the change detection between these 2 time period. And when you want to make the land use land cover change detection, we can apply the 2 types. One is the single class change detection, another is the multiple class change detection. Single class change detection means that in this case, I just only work for single class. Suppose my main concern only about the build up. Okay, I want to make the build up change detection map between these two time period, year of 2013 to 2023. I want to create only for the build up, or I want to make only for the vegetation change detection map. Okay, or water body change detection map only for the single class. Okay, and another is the multiple class at the same time all of classes change detection we can do. So in this case, I also discuss about the urban growth monitoring. So that's why I also explain about that single change detection, as well as also discuss about the multiple change detection, how we can easily monitor at the same time using Google Earth Engine. Okay, so then you can easily get this idea how it will be work. Okay, so first of all, we discuss about that single class change detection, how we can easily monitor. Okay, so let's go. And in this case, we are also applying the random forest classifier. So you also keep just use the same, and you also get that more better result. Okay, so we try to two map. One map is that I can see I put the land use land cover 2013. Another is the 2023. Okay, so this is the two map we can simply put in here, classified and classified one. And further, we are just calculate the accuracy assessment. So this thing I already explained how we can easily calculate the accuracy. Okay. So for the two map, we create the two time land use and cover accuracy. We can calculate this two time in here. And we also try to export this map as a GeoTIFF file format. Okay. From here, you can easily download this land use land cover map. I already write the code in here. So now we try to discuss about, okay, so we also calculate the area. So basically this code I already explained how we can easily make this type of chart, okay, and calculate the area. Okay, but sometimes chart does not work because when you want to work for the big study area, then it creates some problem. So that's why we also learn about that how we can easily randomly how we can easily create the type calculate the area. We also discuss for today's session also. So okay, so let's go try to start. And this is the legend. We already discussed about that. How we implement the legend. Okay. So in this case, I try to explain about that single class urban change detection between these two time period, 2013 to 2023. Okay. So here we already know about that every classes have a unique value. Okay. Because if you check what is the unique value for vegetation, simply click on here. We can get it. Its value is the 0. Okay. 0 means vegetation. Okay, as well as if you want to check for other class, then water value is the 1. Okay, so when I take the training sample, I put this type of value. Sand is the 2. Okay, also you can see about that the build up is the 3. Okay, so in this case I want to work for single class change detection. So that's why I want to just keep my single class. Okay, I want to work for the build up. And what is the value for build up? Build up value is the 3. Okay, just I work only for the 3. When you want to work for the vegetation, then simply select the value of vegetation. When you want to work for the sand land or water body, just only select the value of sand land and water body. So in this case, we concern about the build up change detection. So that's why my value is the 3 for build up. Okay, so let's go. We check the value for build up is the 3. So for that, we take a variable. Suppose I put the variable name is the build up area 2023, and I call the map. So this variable mainly stored this land use land cover map for 2013. Okay, basically this map is stored in this variable classified F1. So when I run my code, you can see in my variable I just put here the classified imagery. Classified 1. Yeah, so here you can see this is the classified 1. Okay, so this variable is stored the layer. I also already add the layer name LULC 2023. Okay, you can see LULC 2023. So this map is stored in this variable classified 1. Okay, and 2013 is stored in this variable classified. Okay, so basically this map 2013 is stored in this variable classified. and classified one, it stored the year of 2023. So now I want to make the single class map for year of 2003 only for urban, only for build up. So for that, just I put here the take a variable build up area 2023. You can put any variable name, and I call the classified one because this variable stored the land use land cover map of 2023, and I set equal to 3. Okay, 3 mainly build up, because in this case I want to make the change detection only for the build up. When you want to make the change detection for water body, vegetation, or any other unique classes or single classes, just write this value, and we can easily get the value from here. We already check it. It's this value is that 3. Okay, if you want to check the other year, suppose 2013, it is also same. Okay, 3. Okay, so 3. So just we put the 3, and now I want to add the layer. So just call the build up area 2023, and I want to create the binary class. Okay, binary class mainly it just 2 class. One class is the urban, another class is the non-urban. Okay, build up and non-build up. So where there is no build up, it show as a gray color, and where there is build up, it show as a red color. Okay, so in this case, I just put here the gray and red, and further I want to put the layer name urban 2023. Okay, urban 2023. So now if I run the code, then it creates the single class map of urban. Okay, then we can get only for the urban map 2023. So now it creates in here urban 2023. So first of all, we try to look for urban map 2023. Basically, it's the urban and non-urban. Non-urban show as the gray color, and urban area show as a red color. So here you can see we got this type of map. So basically here you find out the gray color, it indicating about the non-urban area. Okay, so there is no build up, and red color it's indicating the build up area. Okay, suppose you want to make the only for water body map. Suppose I want to make only for the single class map of water body or vegetation map. So what can I do? Simply change in here. Here you can see the equal. Okay, just put the value of vegetation. For vegetation value is that you can see 0. Okay, just put here the 0. Put the 0. Then this variable is stored the vegetation class, only vegetation class. And I want to display the vegetation map as a suppose a green color. So click to the run. So now it creates the only for the vegetation map in year of 2023. So let's check the result. So you can see we find out the gray color. Gray color means that there is no vegetation. Okay, and green color indicating about the vegetation. Okay, so here you can see get this type of vegetation area. Okay, for this study area we find out this place have vegetation, also this place vegetation, and this is the vegetation map year of 2023. So this is the process when you create any single class map. Okay, just write the only for the value. Suppose you need the water body map in 2023, just put the water body value, then you can easily get it. So in this case, we discuss about the urban because we try to find out the urban change detection between these two time period. So just I put the build up value 3. Okay, and I put the build up color as a red. Click the run. So now we can easily find out that a build up map in year of 2023. So now from this map, from this urban map 2023, I want to calculate how much urban area are available. Okay, suppose in this map, in urban map 2023, I want to calculate how much urban area or build up area is available. I want to calculate. So here again, so we can got this type of urban area as a red color. So now we calculate the total urban area. So let's go try to calculate. So for calculating this urban area, I just take a variable Suppose I put the variable name is that urban area, and I call this build up area 2023 because this variable stored the build up area. Okay, basically when I put the 3, this 3 is for build up and it is stored in this variable. So now I want to calculate the build up area pixel, how much area at the build up. I want to calculate it. So for that, just take a variable urban area and call the build up area 2023 and multiply with this function. Okay, basically this is the function ee.image.pixel area. It calculated the area in square meter. Okay, it calculated the area in square meter. Just with connecting using the multiply function, we connecting with our build up map. Okay, so this is our build up map stored in this variable. So simply multiply and connecting, and then further we try to calculate the area. So if I run the code, so just I put the call the urban area, this variable urban area, and apply the reduce region function. So basically reduce region function help you to calculate for any specific boundary total pixel area or minimum pixel area or maximum pixel area. So a lot of time we use this type of function reduce region to calculate for average NDVI or maximum NDVI or minimum NDVI. But in this case, I want to calculate the total area. Okay, and I already put this e.image.pixel area. So basically it calculated the area and stored it in here. Okay, pixel area. And I want to estimate the number, how much area. So for that, I want to apply the reduce region function. Okay, and I want to calculate the total area. So put here e.reduce.sum. Geometry is my shapefile variable name, and scale is 30 meter. So now click to run and check how much urban area in 2023. Okay, computing. Okay, but we face this type of problem because in this time we applied very big study area. So it show the too many pixel in the region. Okay, it show the too many pixel. So, but you can also use the max pixel allows only for this value, but ensure that you are not aggregating at the higher resolution. Then yeah, okay, it also okay. So in this time it show the message. If I just increase this value, mainly if I just put the low resolution means that high pixel size. If I put, then it also okay. It also compute these things, as well as if I try to put here max pixel value. Suppose I increase the max pixel, simply copy the max pixel, and I put the max pixel highest value 1E13. So then it also okay. So now run the code and check what happened. So basically this type of problem when you face for calculating anything, then try to apply the max pixel value. Okay, then it calculated. Okay, or if you want, you can also increase the scale value, then it also calculated. Okay, so this is the limitation for Google Earth Engine. So when it across the limit, then it not be calculated, as well as also not be make the time series chart also. Okay. So I hope now it will be work. So let's check. So basically it also depend on the study area size. So basically when you want to work for the big study area, then it takes some time. And when you want to work for the small study area, then within very few seconds we can easily get the result. Okay, it's done. So if I run the code, click on here. So it show the result in square meter unit. Okay, we find out the result in square meter. Suppose I want to convert it into a square kilometer. Okay, so let's go try to convert the square kilometer and check it. For after, so for that, for a square kilometer, just take a variable. Okay. Suppose I put the variable name is that urban area 2023 square kilometer. Okay, so you can put any variable name. I put this variable name urban area 2023 square kilometer, and it's a number. Okay, and this number is stored in this variable. So we define the ee.number function, okay, and call this variable name, and you can see this value get from classification. So put here the get function and put this classification, okay, and further divide 1e6. So when I divide 1e6, then we got the result in square kilometer, okay. So let's go try to check the square kilometer result. Just print and click the run. So now it's computing the square kilometer result. We find out in here. So now it's computing this value. So we find out that 2,386 square kilometer area of urban or build up in 2023. Okay, from this map, we find out that urban map. Okay, so just I open only for the urban. Okay, this map, urban 2023, find out this value, how much urban area. It showed the result 2,386.3491 square kilometer. We find out. Okay. So we find out this urban area. So this is the single class urban area. Using the same process, you can also calculate it for single class, vegetation, how much area, water body, how much area. Same approach, just apply and calculate. So now further, we try to do for the same things for year of 2013. Okay. So in this case, we try to make the map for year of 2023. So this is the map, urban map 2023. And the same things we can also apply for year of 2013. Okay. So for that same process we apply. Just take a variable, suppose build up area 2013, and in this case I call the map. So basically in this case I simply call the map LLC map 2013. Okay, in this case I simply call this map 2013. Okay, basically this variable classified this variable stored the map land use land cover 2013. So now from this map I just choose only for the single class, mainly urban. So just I set here equal to 3. Okay. So now for the same way, we try to display the map in year of 2013. So this map show the urban map 2013. Okay. 2000 plus trying to run. So now it create the another layer, urban map in year of 2013. There you can see you can get the two layer. Okay. One layer show the result for urban in 2013. Another is show about the urban in 2023. So it's working. So we generated the two urban map in year of 2013. Another is the year of 2023. So if you can check, this is the map for 2013. So now this map year of 2013 and this map 2023. You can see the lot of field of area increased between this time period. Okay, so you can see this is the map 2023. This is the map 2023, and this is the map for 2013. So a lot of build of area increased between this time period 2013 to 2023. Okay. So now we find out that how much build of area increased between this time period. Okay. And where is the changed and unchanged? We also make the map for urban change detection also. So let's go. For doing these things, just we also calculate the area. Same process we can be apply. And now we calculate the area for urban in 2013. So we try to calculate the area in urban 2013. How much urban area is available in 2013? So same process we apply. Just call this build up area 2013, multiply with this function, and then further just write this code. Okay, and then we also need to apply the max pixel because it's a big study area. So I also write the max pixels and put here 113, and further print the urban area and also calculate the square kilometer. Same process we try to put in here. Just take a variable urban area 2030 square kilometer, okay, and apply the same process. Divided 1 is 6. Then we got the result in square kilometer urban area in 2013. So click to the run. So this same things we can just apply also for year of 2013. So here you can see that computing. It display the result how much urban area was in 2013. It's computing. So we find out that 2007, okay, and this result for the whole Qatar, okay. So we find out that 2007.3896 square kilometer, and we find out that in year of 2023, 2386 square kilometer. So we find out that almost 379, okay, 379 square kilometer area of build up area increased, okay, between these two time period 2013 to 2023. We find out that total 379. Let's simply subtract the two value, 2386 subtract with 2007. Then we find out the 379 square kilometer area. So this is the newly set up, mainly newly build up area, okay. Total 379, okay. Simply subtract this value, then you find out that almost approximately 379, okay. So 379 square kilometer area is newly set up urban area, okay. So this 379 square kilometer area was not in year of 2013, okay. So this to 3079 square kilometer area increased, and we find out in year of 2023. So now I want to find out this 379 square kilometer area where set up the newly urban area, okay. So for that we have to discuss about the change detection, okay. Where is the urban changed, where is the urban not changed? Suppose if you check the map in year of 2013, so you can see some place, suppose this type of place was urban area in 2013, and 2023 also urban area, okay. So that's it, means that there is not much change. But here you can see this type of place, you can check this type of place, just look, we find out that urban is increased, you can see, okay. So this type of place urban is increased. So this is the newly set up urban area in year of 2023, okay. So now I want to make the map. This map represented the newly set up urban area, okay. Suppose this 379 square kilometer area where it create the new urban area, we can easily find out. Suppose this type of place, you can see it show this is the non-urban, but when I just open it, show the urban in 2023, okay. So this is the new growing urban area in 2023, and now I want to create the change detection map. This change detection map is only showing the urban area, which urban area is newly set up in year of 2023, okay. And this urban area is not available in 2013. And how much area we find out? We find out the total 379, okay, almost 379. So let's go try to find out these things. So for doing these things, just we make the urban changed map. So in we take a variable urban changed map and call this build up area 2013. Basically, I call this map a build up area 2013 and also call the urban map 2023 and also call the urban map 2013. Okay, just we simply put the variable name because this variable stored the urban map 2023 and this variable stored the urban map in 2013. So simply subtract, use the subtract function. Okay, so now if I run the code, so in this case I also create the another binary class. So I put the YOLO and red. Okay, so YOLO means that there is no changed and red means that changed. Changed means that it newly set up urban area. Okay, and YOLO means that there is no change for urban. Okay, so let's go try to make the change map. Click on the run. So now I can see we can get this type of yellow color. Yellow color indicating about that this urban is not changed. Okay. So and we find out only for the red color. This red color indicating about the newly set up urban area. Okay. So this urban area was not in year of 2013. Okay. So this urban area newly growing in 2023. And how much area we find out the newly growing? We find out the total 379. Okay, almost 379. When you subtract the 2386 minus 2007, we find out the 379 square kilometer area. So now we find out this type of place, this type of red color, it creates the newly set up urban area. Okay, so this type of place was not urban area in 2013. If you want, you can also check it from here. Just simply open the map. I simply just decrease these things. So here you can see. You can see. This is the map for 2013. This is the map 2013. And this is the map newly set up urban area. Okay. So here you can see there is no urban. There is no urban. But when I just open it, it shows this type of urban area. I can see. Okay. So this type of things is the newly constructed area. Okay. This type of area was not in 2013, but we find out that in year of 2023 we find out this type of area. Here you can see this place. It's the urban. In year of 2023 it also urban. So it means that there is no changed, mainly unchanged urban area. Okay. So in year of 2013 it was urban and 2023 it also urban. So that is not changed. So that's why it show the yellow color. So here you can show the yellow color. Okay. We find out the yellow color. Yellow color indicating the unchanged area, unchanged urban area, and red color indicating about the changed urban area. So this type of newly set up urban area you can find out from here. Yes. So now ask me the question, please.
Thank you. Yes. So there must be some locations that were urban in 2013 and then not urban in 2023. Do we also look at those locations?
Yes. Yes. Because this place have already in urban in 2013 and 23 it also urban area. Okay. So we find out the equal class. Suppose it was urban, and in 2023 it also urban. So there is not change. But when I just calculate the change, we find out this type of newly set up an area. And how much area? Oh, just subtract, we find out that 379 square kilometer area. We find out. Okay, so this is the 379 square kilometer area map, newly set up urban map. Okay, and this type of urban was not available in year of 2013. Okay, in 2013 it's not available, but 2023 we find out this type of urban area.
Thanks. Yes, but what about locations that was urban in 2023 and then not, sorry, urban in 2013 and then not urban in 2023?
Okay, so for that we make the change. Simply we can check this map. Here you can see this is the urban map 2013. So we find out this type of gray color indicating about that there is no urban. Okay, and red color is indicating about the urban. And we already calculated the area, how much urban we already calculated. Okay, 2013. Okay, we find out almost the area is that 2007 we find out. Okay, and we already calculate about, you can see this is the map 2023, and we find out that this type of vertical is the urban and this is the non-urban. Okay, so this is the newly set up this type of thing. So between these two decades, 2013 and 2023, we find out the changed and unchanged urban. Okay, so if the urban in 2013 and 2023 at the same place, we indicating it's a not changed, unchanged urban. Okay, and where the newly set up urban we consider is as a changed urban. So it creates this type of newly set up urban. Okay, so here you can see this map. We find out almost same with our 2013. You can see. Okay, because 2030 we find out this type of place is the new urban, newly set up urban, but 2013 there was no urban.
Thank you.
Sir,
Please.
actually, although this is the well-defined systematic procedure for calculating the change detection, but I also feel, sir, the basically graphs which we have prepared earlier, the chart graph,
Yeah.
and the area is visible over here if you put the cursor. So simply can we also calculate the change in particular class?
Yes, yes, it is also possible. We can also
Uh,
calculate it the urban.
yeah.
Just make the chart. Suppose it's
Yeah.
about the urban change and not urban change. So same process we can also apply, and we also
But
calculate the area.
but as you have rightly said in the beginning that
Yeah.
sometimes you may face the problem in creating the graph.
Yes.
Then this type of procedure is necessarily to be followed, no, sir?
Yeah. So basically, it has some limitation for creating the chart. So that's why we cannot randomly calculate the area, and further
Right,
we
right.
can use the Excel file, and then we can easily make the chart. You know.
Right, sir. Right, sir.
Bilas, excuse me.
Yeah, please.
I just want to know, could we, sometimes there's a confusion between built-up area and construction sites. Does this index show the difference between built-up and construction sites?
Okay, so basically, it also similar spectral we find out for the build up and construction site. So basically, for that, I think you can also try to use the aerial photography. Then you also get the more better or high resolution imagery. Then you also get the more better visualization. But I think it also some another indices. Then we can easily find out for build up and construction site. It also possible because all of build up this type of spectral signature is almost same. Okay, so basically barren land or build up or construction site, so this type of spectral signature or spectral profile almost same. So that's why it's very difficult to find out for build up and construction site at the same time. So it also possible if you want to use the high resolution imagery. Suppose you want to use the aerial photography or drone imagery, okay, for your study area, then you can also easily classify it. For the build up or construction site, we can easily differentiate, or working construction easily differentiate. Okay, so otherwise it's very difficult to find out the build up and construction, because spectral signature is the almost same for the build up, parent land, or construction site, almost same. Yes, please. Yeah, any question, please?
In this map where we are showing the change in the urban area, like the red is the change, but the yellow that we have over here is covering both urban and non-urban in this map, right?
Yes.
Uh, can we like how can we only show the change with respect to like urban? And I mean, because the yellow I felt was covering even non-urban areas. So
Yes.
um, yeah, that was my
Yeah.
question.
So for that, we also apply the self marks. Okay, let me show you that how we can easily apply the self marks, and then this things easily remove. Okay, this type of things. Then we can get only for the urban. And when I just open the two map, suppose urban change map, and then we can easily get it. Okay, so let me show you that. I also try to develop these things. Suppose just urban, because in this time it will show that. So for doing these things, just I put here the dot self marks. Okay, so now it just make the one class. Okay, without self marks we find out the binary class, but in this case I want to just self marks. So now this binary class is not need. I put the one color. Okay, suppose I put the red color. It's indicating about the newly urban area in 2023. Okay, suppose I want to show as a pink color, or any color you can choose. Suppose I put at that pink. Okay, so now if I run the code, and now from here we try to check the result. So this process you can also apply to make the urban expansion map. Okay, suppose different time or different year, how urban expand. Suppose 2030, 2023, or 1990, 2000, 2010, or 2020. For the different time, we find out the urban expansion, and we put the different color for urban expansion. Suppose all of urban in 2000, we find out the another color. Okay, so we put the different color, and then we check the urban expansion. Okay, so let me try to just I keep only for. Okay, so now here you can see now the pink color show as a newly set up urban. Okay, you can see this pink color. Okay, so this type of place is the newly set up urban, or this is the changed urban. This is changed urban, and this type of red color indicating the urban area 2013. Okay, 2013, but 2023 we find out this type of place is the urban. Okay, pink color. Okay, and this is the urban for 2023, and it's create the newly set up urban. Okay, so this type of place there was no urban, but 2013, sorry, 2023 we find out this type of place have the urban. Okay, so you can also represent this way for the change. Suppose this is the changed urban, it changed and create the newly set up area, and this type of urban is available in 2013 and also available in 2023. So that's why the unchanged. Okay, so from here you can easily you can also use this map as the urban expansion, as well as you can also use it for urban scroll. So different way we can also use it. Just use the self marks function. Yes, please.
Yes, sir. Yeah, thank you very much. So,
is it possible to draw like the, because urbanization, is it possible to draw like the buffer zone?
Yeah, it also possible. So further we also make the raster to vector calculation. Okay, suppose we try to find out the raster to vector, and from here we can easily find out that this type of place we can convert into the polygon. Okay, suppose newly set up polygon, so we can see this is the newly set up urban. Okay, so these type of things we can just convert the raster to vector, then we can also apply the buffer zone also. So I will show you this process how we can easily make the buffer zone and also make the convert raster to vector. So one by one I try to explain. Yeah.
Thank you.
Yes, please.
Thank you, sir. Maybe I was getting lost when you were explaining. Is this a RF algorithm or SVM or COP?
So it's a RF,
Which
mainly random
algorithm?
forest. Random forest we try to
Random forest.
Yes.
So, sir, so which algorithm is better to have a higher accuracy for urban growth monitoring?
Okay,
in
so
reality?
maximum paper I check already. So maximum paper they are use the random forest. Okay, they are use the random forest for their classification, and then try to find out that urban change modeling or urban growth monitoring they are use it. So random forest is provide the more better accuracy. Maximum paper is also use it. Yes, please.
Thank you, sir. One more question that I have got is, so the spatial resolution is a 10 meter here, because we are using a you are using a centimeter image. So so by looking at this visualization, there
So
may be some
it's Landsat
errors, of
imagery. It's
course.
Landsat imagery. We use the Landsat
Oh,
imagery for this one. Yeah,
yes.
yes.
So 30 meter, that spatial resolution is too big.
Yes.
When talking about like urban area at all, right? From common sense, I mean. So is it possible for us to use a planet image in this Google Earth Engine platform
Yes, yes,
together,
yes.
sir?
Planet image is also available in Google Earth Engine. Same process. For the planet image, we have to make the another. We need to create the account in Google Earth Engine, and I already make a tutorial. You also try to use this tutorial, and then you can also apply for planet imagery. How we can easily use the planet imagery and make the get the imagery. Okay, so when you can get the planet imagery, then you can easily apply for the land use, land cover, other things, you can easily apply. So just a minute, I try to show you that.
So is it like a just overlaying the planet imagery just in the same Google Earth Engine platform? Is it so,
Yes,
sir?
yes, yes, yes.
Thank you very much, sir.
Or if you want, you can also download the planet imagery from other sources. It also possible. So we also try to watch this tutorial, then try to make the how to access the NICFI satellite data in Google Earth Engine by planet satellite imagery. Okay, it's also available. You also try to check it, and then we can easily cloudly, without downloading, cloudly we can get the planet imagery, and for that we can also use it. Okay, for the making the land use land cover classification also. Okay, and you can easily get it. Okay, anyone any question? Okay, so this is the process. We find out that newly set up urban area, almost 387. Okay, so this is the pink color indicating about this urban area, 379 square kilometer. Okay, so this is the one. So some paper you also check, they are also use the multiple year. Okay, 90, 2000, 2010, or 2024. Okay, for their research work. So using the same process, you can also apply for other year. So in this case, we are just concerned only for the 2 year. So 2013 to 2023. Okay, just we apply the 2 year, and then we check the result. Okay, but using the same process, you can also apply for other years also. Just you need the make the land use land cover classification map for 90, 190, or 2000, 2010. Okay, 2015. For your research paper or research work, just take this and move the analysis. Same process you can also apply. Okay, and this type of map we can easily download as a geotip file format, and I already discussed about that how we can easily work with ArcMap software to create the map layout after downloading the GeoTIFF file format. Okay. So we find out this type of urban expansion or newly set up urban area between these two time period. And further, we already calculate the area. So basically, this is changed area. We find out that total how much area. Just subtract this two value. Then we can easily get the area 379 square kilometer. Okay. Or if you want, you can also calculate the area randomly. Then we also get the almost same. Suppose if I calculate the area, so just write the code. Just take a variable. Suppose urban change area. And then call this urban change map. This thing just simply multiply with pe dot image dot pixel area. Okay? And further we computing this total pixel area. Okay? Take a variable, suppose urban change area. You can put any variable name, and I call it and paste here and apply the reduce region function, okay, to compute the total pixel area. So just put here the all of argument curly bracket start and also curly bracket int, then reducer. I want to calculate the total area, so put here e dot reducer dot sum. Okay. Geometry, it's a shapefile variable name which is ry. Scale is the landscape imagery. We put here the 30 meter. Sorry. Put here the 30. Just a minute. And it was not ready with that. X pixel 1e. Let me. I think I put the insert button, so that's why it looked like this way. So let me check it for insert button. Where is it? Insert. Yeah. So now it's okay. So put at the max pixel 1e13. So now further we try to print R1 change area. So it shows the result in meter, but I want to convert it square kilometer. Suppose square kilometer urban area, and so if I run the code first, suppose just run the code. Now we get the result for a square meter. Okay, so further this square meter area we convert into square kilometer and check the result. Okay, show that user memory limit exists. Let me check on the code again. Okay, I think some issue for user memory limit exists the limit. Okay, let me increase the scale variant check. Suppose I consider the 100 meter and now run the code. Working. So we try to remove the self marks and okay, I put at the mean for 0 and max for 1. I put here gray and pink. Often. Okay, I think some problem or my memory, so the memory limit exists due to the networking issue. Sometimes we get this type of problem, as well as when it across the limit, then we also face this type of problem. So you also try to check it, but this result come from this two subtraction. Suppose 2030, 2386 and 2007. When you subtract, then we can get the result almost 379 square kilometer urban for newly set up urban. Yeah. Okay. So this is the process to find out the newly set up urban area. Just simply subtract, then we can easily get it for the newly set up urban area. Okay. So it's called the single class change detection. Okay, single class change detection. We are just concerned only about the single class. It can be vegetation, or it can be water body, or it can be build up. Okay. Sometime you also need to make the vegetation change detection map between the two time period, as well as also need to create the map for the build up change detection or urban expansion map. Okay, then try to apply this type of procedure then you can easily create this type of things and also calculate the area. Okay. So now we talk about the multiple change detection. Okay. So multiple change detection, we try to make the change detection map at the same time all of classes. Okay, so at the same time we try to make the change detection of the land use land cover for all of classes. Okay, so for multiple change detection, we try to apply. First step is the reclassify. Okay, we need to make the reclassify all of classes. Okay, this is the first step. So you can say I will write this step. So first step, reclassify 0 to 3 to into 1 to 4. Okay, so basically vegetation 0, then 1, then 2, then 3. Okay, this 0 we convert into 1. So vegetation will be 1, water is the 2, sand is the 3, and build up is the 4. So this is the first step for reclassify both of land use land cover classes. We reclassify 0 to 3 to into 1 to 4. So vegetation will be 1, water 2, sand 3, build up 4. Okay, we need to convert it 0 to 3 into 1 to 4. Both of land use land cover map 2013 and 2023. So this is the first step to reclassify 0 to 3 to 1 into 1 to 4. So how I can reclassify it? For reclassify, just we take a variable. Suppose in this case, I take the variable name is the before class, mainly year of 2013. So I call the land use land cover map 2013 because I call this map. You can see this is the map LULC 2013. Okay, 2013, this map. So I simply call this map year of 2013 and I put at the before class. I take the variable name before class. You can put any name. And I call the classified because this variable stored this land use land cover map 2013. So now I want to reclassify the value. Okay, for reclassify, just use here the remap function. Okay, so remap function will reclassify your value. So in this case, I want to reclassify 0 will be 1, 1 will be 2, 2 will be 3, and 3 will be 4. So just I put at the previous value 0, 1, 2, 3, and I put the new value. Sand is the 3, build up is the 4, because we have just make the reclassify. We reclassify our value. Same also for after class. After class mainly year of 2023. Okay, so just we find out the after class and put the classified 1 because this variable stored the land use land cover map 2013. Okay, this map is stored in year of 2023. This variable classified 1. So I also need to reclassify both of land use land cover map. So I take the two variable before class, after class, and put the remap and just put the this type of value. So now it make the reclassify. So when you make the multiple class change detection, first step is that reclassify. We make the reclassify